Hello and welcome back to my channel. In this video, we will be examining the main types of volcanic eruptions. A volcanic eruption occurs when magma formed inside the Earth's interior is ejected onto the Earth's surface. Rocks in the mantle are generally kept in a solid state. The confining pressure inside the mantle is so great that a mineral crystal cannot melt at its normal melting point observed at the Earth's surface. The pressure confines the atoms and molecules and prevent them from flowing apart. The increase in the confining pressure results in the increase in the melting point. Melting can occur if the melting point is lowered through the addition of water or even carbon dioxide. It may also occur if the confining pressure on the atoms and molecules are reduced. It may also occur if heat is added to raise the kinetic energy level of atoms and molecules so that they can flow apart. Thus, rocks inside the upper mantle and the crust can undergo three types of melting. Firstly, there is decompression melting, which is when a rock is held at approximately the same temperature, but the pressure is reduced. This happens because the rock is being moved towards the surface, either at a mantle plume, also known as a hotspot, or in the upwelling part of a mantle convection cell. Secondly, there is flux melting, which is when water or carbon dioxide is added to a rock and the melting temperature is lowered. This often occurs at a subduction zone where water is present in the pore spaces of the subducting seafloor, as well as some of the minerals themselves. Thirdly, there is temperature increase or temperature transfer. This is when magma generated in some other way increases the temperature of the surrounding rocks, causing them to melt. For example, when magma rises from the mantle and intrudes in the rocks of the crust, heat is transferred from the magma to the surrounding crustal rocks, causing them to melt. The melting of rocks inside the earth results in the formation of magma. Magma may be defined as a mixture of molten and semi-molten rocks within the Earth's interior, formed from the partial melting of existing rocks, either in the upper mantle or the crust. Within the magma mix, there are suspended crystals and fragments of unmelted rock, as well as dissolved volatiles, which may separate as bubbles as the magma rises to areas of lower pressure. Some of the liquid may also crystallize during the upward movement. We can talk about three main types of magmas. These are basaltic magma, andesitic magma, and rheolitic magma. The pie charts created by John Wiley and Son shows that silica forms the largest component for all three types of magmas. This is because during the melting of the rocks, both in the mantle as well as in the crust, it is always the most silica-rich components of the rock which melts first to create a magma that is more silica-rich than the rock from which it is derived. However, as the diagram also shows, of the three types of magmas, basaltic magma has the lowest silica content, while rheolitic magma has the highest silica content. Now, what is so significant about the silica content? Silica is formed from the combination of silicon and oxygen. As the rocks cool, the silica start to link together to make chains. These silica chains have the important effect of making the magma more viscous or less runny. So, since basaltic magma has the lowest silica content, it also has the lowest viscosity. On the other hand, rheolitic magma, being of the highest silica content, has the highest viscosity. Now, this table shows that rheolitic magma has the highest viscosity, as we just said, followed by andesitic magma, while basaltic magma has the lowest viscosity. This also means that of the three types of magmas, basaltic magma is the most fluid in nature. Notice also from the table that the viscosity of the magmas is related to three other characteristics of the magma. That is the composition of the magma, the gas content, as well as the temperature of the magma. Let us examine each of these types of magmas. Basaltic magma is thin and runny. It has a low silica content compared to the other types of magma and a smaller amount of dissolved gases. It also has the highest temperatures. Basaltic magma forms due to decompression melting in the asthenosphere. Though it has silica, the silica content is not as high since the crustal source has not been incorporated in it. Basaltic magma commonly exists at divergent plate margins as well as oceanic hotspots. At the other extreme, rheolitic magma is thick and slow moving. It is filled with gas and water. Pressure often builds up in this magma as the gases are trapped by the silica chains within the magma. Rheolitic magma formed due to the melting of continental crust due to the heat transfer from intruding magma. The new magma formed from the melting of the continental crust is highly rich in silica due to the composition of the continental crust itself. This magma is then incorporated into the existing magma. Thus, the rheolitic magma has a high viscosity. Andesitic magma is an intermediate magma which consists of about 60% silica. It is thicker than basaltic magma but thinner than rheolitic magma. It tends to move and erupt at an intermediate pace. Andesitic magma mainly form along continental to oceanic subduction zones. The increase in the amount of water lowers the melting temperature, causing magma to form. Now, the type of eruption is largely influenced by the nature of the magma, especially its gas content. The gas gives magmas their explosive character because the volume of gas expands as pressure is reduced. Mafic or basaltic magmas are non-explosive. This is because the magma loses its gas content quickly because of its lower silica content. On the other hand, rheolitic magma is the most explosive because of its high silica content, which results in gas being trapped in the magma for a longer time, so that pressure builds up inside of the magma. Now, this graph being shown, obtained from geology.com, shows that generally the lower the explosivity of the volcanic eruptions, the more frequent they occur. Thus, eruptions involving basaltic magma occurs more frequently than those involving andesitic and rheolitic magmas. Now, let us talk more about the types of eruptions. Uh, we can place volcanic eruptions under two broad categories. We can talk about effusive eruption and we can talk about explosive eruption. Effusive eruptions involve the outpouring of basaltic magma that is relatively low in viscosity and in gas content. It is a calm eruption. Explosive eruptions generally involve magma that is more viscous and has a higher gas content. Such magma is often shattered into pyroclastic fragments by explosive gas expansion during an eruption. We can further divide the volcanic eruptions into 6 other categories. Generally speaking, the 3 most effusive types of eruptions are Icelandic, Hawaiian, and Strombolian eruptions. The 3 most explosive types are Vulcanian, Helian, and Plinian eruptions. Let's look at these. The first and most peaceful type of eruption is named after Iceland, which sits above an area where there is an interplay between a divergent plate margin on the mid-Atlantic Ocean ridge as well as a powerful mantle plume. The Icelandic eruption involves the easy escape of gas so that the low viscosity basaltic lava flows out of long parallel fissures almost in a water like manner. The large quantities of basaltic lava may initially fill in any gaps on the surface to form a vast horizontal plain. Over time, the thin sheets of lava may solidify on top of each other to create a plateau. One plateau created this way is the Deccan Plateau of India. Another example is the Colombian Plateau of the USA. The next eruption is named after the US state of Hawaii, which was formed above a hotspot or mantle plume in the interior of the Pacific Oceanic Plate. The diagram or the photograph shows Mauna Kea, which is a shield volcano resulting from this type of eruption located on the big island of Hawaii. Hawaiian eruptions are similar to Icelandic eruptions, but involves more noticeable central activity. That is, instead of escaping from a fissure, the lava escapes through a central vent. Like Icelandic eruption, it is characterized by effusive eruption of very fluid basaltic type magmas. A single flow spreads widely over open slopes. Steady production of this lava will build up a large, broad volcano known as a shield volcano. The third type of volcanic eruption is the Strombolian eruption. This is named after Stromboli Island in Italy. Stromboli Island is an island in the Tyrrhenian Sea off the north coast of Sicily, containing a composite or stratovolcano called Mount Stromboli. Strombolian eruptions involve basaltic to andesitic magma from vents and are driven by the continuous formation of large gas bubbles within the magma. Upon reaching the surface, the bubbles burst with a loud pop, throwing incandescent volcanic bombs in the air. Because of the high gas pressures associated with the magma, episodic eruptions occur at intervals ranging from minutes to hours. The eruption is considered to be mildly explosive and produces a low elevation eruption column. Strombolian eruptions usually produce little or no lava. As a result, the cones that are produced by this type of eruption is a very steep-sided cone called a cinder cone. Though Mount Stromboli, from which the eruption is named, is not itself a cinder cone, a good example of a cinder cone that also involves Stromboli eruption is Paracutin in Mexico. Now, the fourth type of volcanic eruption is called Vulcanian eruption. Vulcanian eruption is named after Volcano Island, which is a small volcanic island belonging to Italy in the Tyrrhenian Sea, and it is near Stromboli Island and north of Sicily. The island itself is named after Vulcan, the Roman god of fire. Volcanian eruption is more violent and less frequent than Strombolian eruption. It involves andesitic to rheolitic magma erupting from a central vent. Intermediate viscous magma within the volcano makes it difficult for gases to escape. This leads to the buildup of high gas pressure, eventually resulting in an explosive eruption. They form eruption columns, often reaching between 5 to 10 kilometers above the vent. The ash plume builds a cauliflower shaped head and a thinner, more tree like base. When the volcano quits erupting ash and gases, it then ejects thick, pasty lava. Volcanian eruptions usually build a steep sided cone that is more symmetrical than cinder cones. This more symmetrical cone is called a stratovolcano. Sakurajima is an active stratovolcano and is the most active volcano in Japan. Sakurajima has been the site of Vulcanian eruption almost continuously since 1955. Now we move on to Pelian eruptions. Pelian eruptions are a type of volcanic eruption named after Mount Peli, located in the northern part of the Caribbean island of Martinique. It is named particularly after the 1902 volcanic eruption. This type of eruption involves andesitic to rheolitic magma and is associated with explosive outbursts that generate pyroclastic flows. Pyroclastic flows are dense mixtures of hot volcanic fragments and gases which move quickly down a slope under the influence of gravity. The mechanics of the Pelian eruption are very similar to that of the Vulcanian eruption, except that in the Pelian eruptions, the volcano's structure is able to withstand more pressure. Hence, the eruption occurs as one large explosion rather than several smaller ones. One of the most recent examples of this type of eruption occurred on April 9th, 2021 from La Soufrière located in the northern section of St. Vincent and the Grenadines. The eruption also involved powerful pyroclastic flows. Now, the final type of volcanic eruption is the Plinian eruption. This eruption was named after a Roman scholar called Pliny the Elder, who was killed by the eruption of Mount Vesuvius in Italy. The account of the incident was then described by the historian Pliny the Younger, who was his nephew and eyewitness. Now, Plinian eruptions result from a sustained ejection of andesitic to rhyolitic magma into eruption columns that extend up to 45 kilometers above the vent. The eruption of the uprushing gases and volcanic fragments have been compared to a gigantic rocket blast directed vertically upwards. As it reaches higher, the plume expands and becomes less dense, and convection and thermal expansion of volcanic ash drive it even further up into the stratosphere. At the top of the plume, powerful prevailing winds drive the plume in a direction away from the volcano. Lightning strike caused by a buildup of static electricity are also associated with the event. The nearly continuous jetting blast often pours out the magma conduit and rips it apart. As a result, this type of eruption creates enlarged craters as well as calderas. Within the crater of some of these volcanoes, small acid lava dome may sometimes form. Lava domes form because the lava is so thick and flows so slowly, it cannot flow far from the vent. As such, it solidifies into a dome around the vent. The illustration shows a dome formed in the crater of Mount St. Helens, which is a stratovolcano. One volcano which has experienced Plinian eruption in relatively recent times is Mount Pinatubo in the Philippines, which erupted on June 15, 1991. From July to October 1992, a lava dome was built in the new caldera as fresh magma rose from deep beneath Pinatubo. Now, though volcanic eruptions are best known for their disastrous impact on lives and properties, I would like to focus the last part of this video on some of the positive impacts of the events on human societies. If you would like to know more about uh, the negative impact of volcanic eruptions, I will leave a link to another video in the description box. Now, one advantage of volcanic eruptions is their ability to create new lands and new landscapes. When plates separate at divergent plate margins, magma moves upward through the gap to create new oceanic crusts. Thus, new lands are formed from the volcanic eruption. This can be seen in Iceland, for example. Additionally, as lava and tephra are ejected onto the Earth's surface, new landforms are created, both on the continental crust as well as the oceanic crust. As a result of volcanic eruptions, plains, plateaus, as well as cones have been created on the surface. Many islands, including the islands of the Eastern Caribbean, also originated from volcanic eruptions. The Earth's interior is too hot and far for scientists to carry out direct investigations. However, through volcanic eruptions, scientists have discovered more about the Earth's interior as they are able to examine the type of materials which come from the interior as well as the way they arrive at the surface. Through volcanic eruptions, many valuable minerals are made available to human society. Diamonds and most of the world's copper are mined from extinct volcanoes. Sulfur is also mined from active volcanoes. These activities bring income to the economy. Active volcanoes also offer the possibility of the extraction of geothermal energy. Volcanoes are the most important sources of geothermal energy, and geothermal energy is a renewable energy source, therefore, leaving a very small carbon footprint. Now, following an eruption, lava and tephra form igneous rocks, which later weathers to create very fertile soils. Winds may also carry volcanic ashes and deposit them into agricultural fields, which help to enrich the soil. Thus, the agricultural sector can develop, which in turn contributes to food security as well as increased income. With volcanic eruptions making the news headlines quite regularly, volcano tourism has emerged over the last decade as an important sector of the tourism industry. Volcano tourism is where tourists travel to countries to enjoy views of erupting volcanoes as well as to view the landscapes created by volcanic activities. This type of tourism is now increasing in countries such as Italy, New Zealand, and Iceland, especially as a form of sustainable tourism. Again, this helps to bring income to these countries. So now I am going to leave you with two CAPE Unit 1 past paper questions that you could attempt on the topic for yourself. The first question can be written as an essay. So you may be given a total of 2 marks for a good introduction and conclusion. All right, leaving 8 marks to be gained. Then for each type of volcano you talk about, you need to make 6 strong points so that you can earn 6 marks each. 2 points may be earned for maybe describing two characteristics of the volcano itself. 2 points may be earned um, for describing the eruption and how it is related to the characteristics of the volcano, and another 2 points may be earned for talking about the lava which forms the volcano. Now, even though you are asked to talk about the lava, remember that lava is just another name for the magma when it is at the surface. So use what you have been taught about magma to talk about the lava. For example, basaltic lava flows readily and can form extensive lava plateau through Icelandic eruptions. Very viscous lava derived from andesitic to rhyolitic magma can, on the other hand, form acidic lava dome during the late phase of a Plinian eruption. Andesitic magma gives rise to viscous lava and tephra, which can form stratovolcano during a Vulcanian as well as a Pelian eruption. For the second question, you can simply talk about um, any 3 of the advantages that I have described in the video, such as thermal power, agriculture, mining, tourism, and so on. You must ensure, however, that you clearly show the connection between these advantages and the volcanic eruption. Okay, so thank you again for watching. I encourage you to do further reading on the topic and definitely to attempt other past paper questions that are related to this topic. Continue to support my channel by liking this video, sharing it with someone, and definitely subscribe.